Well, that's the problem. The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all.
A galaxy, and the nearest galaxy to us is the Andromeda galaxy, and we think they're all.
The Andromeda Nebula overnight became the Andromeda Galaxy.
Or about 100 billion galaxies in the visible universe.
Well, that's the problem. The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe. In a monumental development, the James Webb Telescope, perched at the forefront of astronomical exploration, has intercepted a signal of unprecedented significance emanating from the distant Andromeda galaxy. This cosmic communication has set the scientific world ablaze with anticipation, sparking a frenzy of speculation and intrigue. Could this be a cosmic anomaly or a sign of intelligent life beyond our solar system? Join us as we uncover how the James Webb Telescope has just received an alarming signal from Andromeda Galaxy, the cosmic lens of discovery. Long ago, when early astronomers peered into the night sky, they saw the Milky Way as one big blob of light. They didn't have fancy tools to see individual stars. But along came Galileo Galilei with his telescope in the 17th century. He showed them that the Milky Way is a collection of countless stars. This blew people's minds and made them wonder if there was more out there. Then in the 1920s, Edwin Hubble rocked the world of astronomy with his powerful telescope. He spotted galaxies far beyond the Milky Way. This was groundbreaking. One of these galaxies was Andromeda, also called M31. Even way back in the 10th century, before telescopes, a Persian astronomer named Abd al-Rahman al-Sufi saw Andromeda as a faint smudge in the sky. As technology advanced, scientists got better at studying Andromeda. They realized it was not just a blurry patch in the sky. It was a massive galaxy like our Milky Way but incredibly far away, about 2,537,500 light-years. They've gone from winking through telescopes on the ground to using cutting-edge space observatories like the Hubble and the James Webb Space Telescope. These telescopes let them peek deeper into the mysteries of this distant galaxy, unraveling its secrets one star at a time. Each time they invent a new tool, they get closer to fully understanding what Andromeda is all about. Knowing how Andromeda is put together and what it's made of helps scientists learn more about the whole universe. It's like having a big puzzle, and understanding Andromeda is like finding a piece that helps them see the bigger picture. Plus, it's like having a twin galaxy to the Milky Way, so they can compare them and figure out how galaxies form and change over time. The James Webb Telescope is like a superhero telescope compared to the older ones, and it's found some really interesting stuff in Andromeda that's shaking up what they thought they knew. This super telescope has spotted some weird stuff going on right at the center of Andromeda, stuff they've never seen before. Scientists all over the world are scratching their heads over this. The signal suggests that some really important things are happening inside the galaxy, maybe something to do with its super huge black hole, or some things they've never even imagined. One of the big discoveries is that Andromeda might not be as big as they thought before. They thought it was way bigger than our Milky Way, but now with new measurements, it looks like they're more similar in size. This changes everything about how they see our galaxy in the big galactic neighborhood. Furthermore, the James Webb Telescope has given them clearer pictures and information about Andromeda. These reveal fresh details about how stars are born and what elements make up the galaxy. Another interesting find concerns the active heart of Andromeda, called its galactic nucleus. The data shows that the black hole at its center is more active than they previously thought. This heightened activity doesn't just stay put, it affects the space around it, and could even shape the future structure of the entire galaxy. The telescope's observations also shed light on the mysterious dark matter. Kaku mentions that by studying how Andromeda's stars move under its gravitational influence, scientists can get a better grasp of how dark matter is spread out across the galaxy. This is crucial for tackling one of the most puzzling questions in astronomy: what exactly is dark matter and how does it influence the universe? These recent revelations from the James Webb Telescope have sparked a flurry of research. Scientists all over the world are delving into the data, eager to unearth more of Andromeda's mysteries. Each discovery adds another puzzle piece to their understanding of the galaxy's past and future, painting a clearer picture of how the universe operates. Andromeda's magnificent secrets captivate astronomers and differentiate it from other galaxies. To start with, Andromeda's sheer size is impressive. Recent data suggests it stretches across about 220,000 light-years in diameter, making it one of the biggest galaxies in our cosmic neighborhood and similar in size to our own Milky Way. Its large dimensions are home to an estimated 1 trillion stars, outnumbering those in our galaxy. But size isn't the only remarkable aspect of Andromeda. Its structure adds another layer of fascination. While it sports the classic spiral shape common among galaxies, Andromeda has its unique abilities. It flaunts a swollen center and a dense core encircled by bands of dust and gas where stars are actively being born. These characteristics hint at a lively galaxy with constant processes shaping its appearance and evolution. The core of Andromeda holds particular allure due to an unusual feature known as double peak emission, hinting at the possible existence of a supermassive black hole. This event parallels what they've observed in the Milky Way, but studying Andromeda's black hole provides vital insights into these mysterious entities. Furthermore, Andromeda isn't alone in space. It's enveloped in a vast halo of stellar matter stretching hundreds of thousands of light-years. This halo comprises stars, planetary nebulae, and globular clusters, offering a look into the galaxy's detailed history and formation process. The clusters of stars, called globular clusters, are particularly interesting to scientists. There are more than 460 of these clusters in Andromeda, and they provide valuable information about how galaxies like ours were born and how groups of stars behave together. Another interesting aspect of Andromeda is its collection of smaller galaxies that orbit around it like satellites. There are over 20 of these smaller galaxies, and some of them are gradually losing their stars and gas as they get too close to Andromeda. This process, known as galactic cannibalism, shows how galaxies can grow by swallowing up smaller ones. But what's even more captivating is how Andromeda is changing and what its future might be like. Scientists are strongly curious about this and are studying it closely. One big change that might happen to Andromeda is that it could transform from a spiral galaxy into a ring galaxy. Observations hint at shifts in its structure that could lead to this rare form. Ring galaxies are pretty special and usually happen after galaxies collide or nearly miss each other. So if Andromeda is heading towards this transformation, it suggests that it's had some close encounters with other galaxies in the past. Andromeda's future is also tied to our own Milky Way galaxy. Scientists predict that in about 4 billion years, Andromeda and the Milky Way will collide and merge. While this might sound like a cosmic disaster, it's a normal part of how galaxies evolve. Thankfully, because of the vast distances between stars, the collision won't involve stars crashing into each other directly. It's a slow dance of gravity reshaping the galaxies over millions of years. However, when the galaxies come together, their combined gravitational forces will have a deep impact, reshaping them dramatically. As they merge, the gas and dust within each galaxy will collide and interact, sparking off fresh waves of star formation. This rise of star birth will illustrate the merging of galaxies, resulting in an extraordinary celestial display unlike any other in the universe. This event holds a special significance for us humans due to our direct observation and involvement. Moreover, the supermassive black holes situated at the centers of both galaxies are poised to merge as well. This union may unleash significant emissions of radiation as the surrounding matter is consumed by the newly formed black hole. So what lies ahead for the fate of our solar system amidst the impending merger of Andromeda and the Milky Way? Michio Kaku reveals that while the annihilation of the solar system is improbable, its circumstances and position are likely to undergo considerable changes. These changes could manifest as shifts in orbit, or even expulsion from the newly formed galaxy altogether. Understanding these complicated processes not only aids scientists in foreseeing the outcomes of similar happenings elsewhere in the universe but also furnishes vital context for understanding the eventual destiny of our very own galaxy. The cosmic dance of Andromeda and the Milky Way is like trying to figure out the big forces and changes that happen to galaxies over many, many years. It's like watching a slow-motion dance of stars and planets, trying to understand where they'll go next. They're particularly curious about what will happen when our galaxy, the Milky Way, and Andromeda merge. It's like two giant cities coming together. There's bound to be some commotion. When they say merge, they don't mean stars crashing into each other like in a movie. Instead, it's more about the big invisible forces at work. Imagine two giant magnets getting closer and closer. They might not touch, but they'll feel each other's pull. This merger could shake things up in our cosmic neighborhood. Stars that once had predictable paths might go spinning off in new directions, including our own sun. And if our sun moves, Earth might feel the effects. If Earth gets closer to the sun, it might start feeling like a hot summer day all year round. That could mean trouble for polar bears and penguins as their icy homes melt away. But if we move farther away, we might need to break out the winter coats for an eternal frost. This galactic mashup could also bring more radiation our way. As the black holes at the centers of the Milky Way and Andromeda do their thing, they might send out waves of energy that could mess with Earth's atmosphere. We might have to get creative to protect ourselves from this new cosmic weather. While it's exciting to think about our galaxies getting closer, scientists have more to study and understand about what might happen. It's like planning for a big party. They need to know what to expect so they can be ready for any surprises. To wrap up, Michio Kaku emphasizes the importance of exploring Andromeda for the answers it holds. He states that, like our pursuit of understanding life's origins, our exploration of the universe aims to discover profound truths about our existence. As we gaze at Andromeda, we are reminded that the pursuit of knowledge and the quest to comprehend the cosmos are perpetual. Every discovery propels us forward in our journey to unveil the mysteries of the universe, leading us closer to the answers we seek.